All right, here's a short little video on coordinate proofs. These we will explore later on in greater detail. The proof that I'm going to do in the video is that FGHI is a parallelogram. So here is FGHI. Notice from the diagram that we notice, for example, that the distance from here to here is A. We can tell that by the coordinates, A comma B, right? Then we also know that the distance from here to here is C. We can also see that vertically, both G and H are the same height as our F and I. From the X coordinate, just one's up and one's down. So they carry those negative signs. And likewise, going backwards, you can see that the distance here is negative C and then negative A. All right, well, you recall from the previous chapter, proving something is a parallelogram has multiple options. They mainly deal with the opposite sides. And so you could show that opposite sides are parallel. That would be based on the definition of a parallelogram. And you recall that parallel is referenced with slope in algebra. And finally, we could show that opposite sides are equal. And that is the distance. And we haven't talked too much about the distance formula per se. That is coming up a little bit. But you do know Pythagoras, so that's one thing we could look at. I'm going to use that one pair of sides is both parallel and equal. Now, unlike other proofs, we don't mention a lot about justifications here, but I'm going to take those two sides, Fi and Gh, and I'm going to show that they're parallel and equal in distance. Know that it would have been much easier for me to pick these two sides here. There's several arguments I can propose about why those are parallel, and it's rather simple to talk about distance between those 2 points as well. All right, Fi, the slope, I have to subtract 2 coordinates, and I have to then divide them. So if I look at F and I can see my X coordinates and my Y coordinates. Yeah, so here goes. We'll do it this way so we can kind of keep an eye on the diagram above as well. So the Y coordinates are B and negative B. Got that negative on the wrong side there, I see that. And then negative C minus negative A. So if I summarize, that looks like it's 2B over negative C plus A. Now doing the same thing, looking at the slope of GH, we can see that we've got, again, B minus negative B, and then A minus C. So I've got, again, 2B and then A minus C. Now if I look at my two slopes here, they look a little different, but in effect, these are the same expression, right? Because any subtraction can be thought of as an adding of a opposite. So these are the same. Therefore, that's a fancy symbol for therefore. Therefore, the lines are parallel. So Fi and GH are parallel. All right? Now I'm going to show that the distances are equal as well. Now to talk about distances, I am not going to use the distance formula as some of you might know it. I'm going to just use the Pythagorean theorem. And you recall the Pythagorean theorem talked about a triangle, and namely that the leg and the leg versus the hypotenuse. So here are my two legs, and here's my hypotenuse. So I'm going to show that the hypotenuses are the same on both sides. So distance of Fi. So how far is it from there to there? Well, that would be the difference between A and C, correct? So if I subtract negative C minus negative A, right? And then I take that quantity square that. Add that to the distances between the b's. How far is it from b to negative b? So I'm going to take and subtract b minus negative b and square that. Order is not a real big deal here because we're squaring, and if you have a negative on a number, it'll disappear. Now keep in mind, I'm then going to take the square root of this expression. So I've got negative c plus a squared, and then here I've got, again, 2b squared. So this is going to be the square root of negative c plus a squared plus 4b squared. And that's as far as we can take that. Okay, that's cooked. Now I'm going to look at GH. And again, we've got a square root, and then I've got a sum of two squares. Again, that's Pythagoras, right? So I come over again to this side here, and I go, okay, how far apart are they from here to here? Well, that's a minus c, and that's 2b, the other one. So again, I'm going to go a minus c squared, and then I've got 2b here. So we can see that, again, I've got a plus negative c squared plus 4b squared. So these two have the same distance. Therefore, my final conclusion, thus FGHI is a parallelogram, because I took two sides and I showed that they were both equal in distance and had the same slope.